Oh, yeah. Thank you for coming all the way through Snowcalypse. And my name is Jaewon. I work at Coupang. And today I'd like to talk about RedisJSON, a Redis module. Recently in Coupang, I have done some benchmark tests against RedisJSON. And I'm going to share the results with you guys today. And before diving into our discussion, I wanted to mention that it's a real privilege to be here. Thank you for having me today. Really appreciate it. Here's today's agenda. I'm going to share the story why Coupang loves Redis and how we are using it. And I'm going to share the brief introduction about RedisJSON. And lastly, I'll talk about our benchmark result comparing various data types like string or hash or RedisJSON. To start off, I'll explain a little bit about my company, Coupang, to give you guys a better context. Coupang is an e-commerce tech company, and it's one of the fastest growing startups in the world. And we're the biggest e-commerce company in South Korea. For those who don't know Coupang, this is how it works. First, we have a mobile app, of course. And then when a customer buys something from Coupang, then the order is sent to a fulfillment center to get it ready. And then our delivery man take care of the last mile experience for customers. One of the interesting parts in here is that we own tens of our own physical fulfillment centers to provide a same day or next day delivery. So most of the orders are fulfilled within 24 hours. This service is called Rocket Delivery, and you can think of this Rocket Delivery as an upgraded version of Amazon Prime. No offense. Yeah. So this is the landing page of Coupang website. Not that much special. We have a search bar and button for categories and stuff like that. And what else do we have? Can you guys make a guess? It's advertisement. Yeah. Then which part in this website is advertisement? Yeah. The banner at the top, its right part is ad. And the big carousel at the center is an advertisement too. And this part too, yeah, pretty much all of it. This advertisement business is a great source of revenue, and it's also beneficial to our sellers simply because they can sell a lot of products thanks to the super high traffic of Coupang. I'm not bragging about my company. What I want to say is that this advertisement business is one of the most critical services in Coupang for both ourselves and our sellers too. This is the extremely simplified version of Coupang ad platform. To give you guys an idea, actually it's way much cooler than this. Sorry for my design skill. Anyhow, we have a seller at the left of the diagram, and he or she pays money to Coupang for their products to be advertised. And then when a Coupang customer opens up their mobile app, this ad platform will provide necessary advertisement information to the mobile app over the network. As some of you guys already might have noticed, there are a few caveats here. First caveat is that the space of the device screen is not enough. That means one of the requirements of this advertisement platform is finding out the best advertisement for that specific customer. And second requirement is that P95 RTT, the round-trip time latency, should be less than 20 milliseconds, because otherwise it will directly affect our customer experience. And lastly, we are handling over 15K TPS at daily peak. So with that being said, this ad platform should provide a really performance service. So what's the fastest data store in the world?
Redis.
Yeah, Redis, thank you. Yeah, Coupang loves Redis, and Coupang ad platform is integrated with Redis for fast data store and retrieval. So long story short, this is why we are using Redis. And I'd like to a little bit talk about our data model here. Our data model is JSON formatted. So if you ask why JSON, the answer would be simple. because JSON is human readable and it's a universal format. So most of the programming languages and tools support JSON, so it's really convenient to carry around. Let me explain a little bit about our data model here. So when a customer comes in to Coupang, a single piece of information is generated for identification purpose. I will call it customer key here. And then this customer key naturally becomes the Redis key. And for each customer key, we have a associated JSON value. And inside of JSON, we store advertisement information. So basically, the whole process is like this. When customer comes in, we retrieve the whole JSON block, the whole advertisement information. Then we decide which advertisement should be exposed for that specific customer. Then finally increase the cap value to put a limit on the total count of exposure. So that's how it works. So now that we have Redis in our system and our JSON data model, it all boils down to how we handle JSON in Redis. In Redis, there are two traditional ways to handle JSON. One is string, and the other is hash. I will not talk about more advanced ways like Lua scripting today. Here's a brief demo. As I explained in the previous slide, our operations consist of 3 steps. First, we retrieve the whole JSON block first, then increment a single field, then put it back to Redis. So in case of string, we do get to retrieve the whole JSON first, and increment a single field, then lastly, we do set to save the whole JSON back to Redis again. And in case of hash, we do hgetAll to retrieve the old fields of JSON, then increment a single field as well. Then in case of hash, we do hset to set a single field to back to Redis. So we had to decide between string or hash, but one of my coworkers suggested another idea. It's RedisJSON. So RedisJSON is a Redis module which enables Redis to handle JSON as a native data type, like other built-in types like string or hash, list, set. Then what does this native data type mean? That means RedisJSON provides various commands for JSON like this. With RedisJSON, we can save JSON data with JSON.set command. As you can see in this example, the first parameter is my JSON, the Redis key, and the second parameter is dot, which means the root of JSON, and the last parameter is the real JSON data. And we can retrieve it with JSON.get command, like that. Another example. One of the best things of RedisJSON is that we can save nested JSON too. As you can see here, I saved the nested JSON. Also, we can use JSON path style syntax to access a specific field. With this JSON path style syntax, it's possible to get a specific field or even increment it. I think this num increment by command at the last is especially useful because it's really network efficient and you don't have to care about race condition because race handles it. Redis itself guarantees atomicity, so just run this command, then Redis guarantees atomicity. And also, RedisJSON provides a lot of other useful commands as well, so please check it out later. It's really cool. OK, so now we have 3 options in total to represent JSON data in Redis: string, hash, and RedisJSON. But as you know, it's all about trade-offs. It's very important to understand the pros and cons of each case, and you need to make sure if it's a right decision for you. So let's go over the pros and cons briefly. First one, string. It's memory efficient and super fast in general. But with string, one of the downsides of string is that it does not understand the JSON format. That means you need to save or retrieve the whole JSON block. It could end up eating your entire network bandwidth. Network is also a limited resource too. So the next con is, in case of string, if you want to update the different field in a JSON at the same time, then it's not atomic. For example, let's assume that there are multiple clients out there trying to update different field in a single JSON. Then one of the clients will override the field that another client updated. And with hash, let's go over to hash. With hash, some of the downsides of string can be solved. We can do atomic field update, and we can do single key retrieval, so it's really network efficient. But one of the downsides of hash is that it's just a simple key value. It does not support nested JSON. So yeah, it's just a dictionary. It's not about JSON. It's just a Redis hash. That means if you want to handle real JSON, not Redis hash, then probably you have to convert it back to JSON in your client side. Now, RedisJSON, it looks really prominent. Yeah, we can do atomic field update and single key retrieval. And it also supports full JSON, so we can save nested JSON too. And it's strongly typed and Redis native. And it's all about JSON, so you don't have to convert it back and forth in your client side. It's really cool, but we didn't know anything about its downsides, so we decided to do some benchmark tests. This is the topology of our benchmark test. We use Redis cluster version 5.05, 6 nodes in total, 3 masters, 3 slaves, and each Redis is running on a separate virtual machine with 128 gigs of RAM. And as a load generator, I use YCSB. I'll talk about YCSB in a minute soon. And inside of YCSB, I used Redis as a client library with round robin and some connection pooling. And to guarantee enough CPU cores and network bandwidth, YCSB is running on a pretty powerful machine here. Yeah, before jumping into our benchmark results, let's talk about some caveats in our benchmark. I used YCSB instead of Redis benchmark. That's because I wanted to simulate our production workload as similar as possible. And this YCSB provides some kind of flexibility while still we can depend on its core features like instrumentation or parallel running or throttling. And another caveat is benchmarking latency is not always fair. There is a lot of factors and variables out there that can affect the benchmark result. For example, network bandwidth or disk operations like AOF or RDB, or even client-side configurations like connection pooling, pipelining, etc. We try to be fair as much as possible, but there's always some kind of bias in every benchmark. So please take our result with a grain of salt. Yeah, this is the first result of our benchmark test. It measures RTT latency, round-trip time latency in client side. And x-axis means the number of fields in JSON. And y-axis is the latency, RTT latency. And dark colored bar is about RedisJSON, and red one is hash, and green one is string. The reason why x-axis is the number of fields is that fields grow as we have more advertisement in our advertisement system. Yeah, when the JSON object is small enough, like just 5 fields in it, they all show almost same performance. It's pretty fast. It's around 1 millisecond, and there's no practical difference. But as you can see here, in case of RedisJSON, the latency surges as JSON object gets larger. And in case of hash, latency goes up a lot too, but not that much compared to RedisJSON. And this is the result of another benchmark test, almost same with before. It measures RTT latency, but this time it's about updating a single field of JSON. So yeah, in case the JSON object is small, like just 5 fields in it, they all show almost same performance. All of them are pretty fast. But in case of RedisJSON, latency surges again. But it's interesting that hash still shows sub 10 milliseconds latency, even for 10K fields. It's pretty fast. This is our final benchmark. We wanted to see the RAM usage for each case because Redis is an in-memory data store, so RAM usage directly translates to the cost of running Redis. To see the RAM usage, we check the used memory dataset section of a Redis info command. I used string as a yardstick here. Hash generally shows around 50% more memory compared to string. And RedisJSON is almost 4 times more memory compared to string. Whether the number of fields is small or not. This result was quite surprising to us, so we wanted to know why. The reason why latency goes up as the number of fields grow is that the time complexity of path evaluation is big O n by m. N means the height of JSON, the number of fields, and m means the width of a JSON, the level of nesting. That means RedisJSON gets slower as your JSON data model gets bigger or more complicated. And the reason why RedisJSON needs more memory than hash or string is that it needs to parse JSON into a tree structure to handle it in a Redis native way. RedisJSON is internally using a JSON lexer, and after this lexer parses JSON into a tree, it shows some overhead in the memory usage. Yeah, this is the key takeaways from today's talk. The conclusion is, go for RedisJSON if your JSON data model is simple enough. It is still pretty fast, but you can enjoy a lot of perks. And also, this is the most important thing, I think. RedisJSON is getting improved. The new version of RedisJSON, version 2, is out now. And it looks like the maintainers of RedisJSON are trying to provide secondary index feature with Redis search, which is another Redis module. So they are trying to make some synergy between Redis modules, which is really nice, I think. Yeah, this is what I prepared for today. And I'd like to wrap up my talk with this. While we ended up not using RedisJSON, but I still think it's a nice tool, great tool. So if you think your data model fits into RedisJSON, then please give it a try. And big kudos to Redis Labs for this great open source project. Final comment: Coupang is hiring. Please hit me up if you're interested. Thank you.
Great. Thank you, Johan.
Yeah, sure.
Excellent presentation.
Yeah.
Are there any questions before he wraps it up? Any questions? Oh, there are questions. OK. Hold on a second. All right.
Thanks. I never use Redis, so when you're doing this benchmark, all of the data is in the Redis, or they are in a different database?
All of them are in Redis.
OK,
Yeah.
thank you.
Anybody else? Yes.
So you mentioned actually you end up not using Redis.
Yeah.
Could you share your mind why?
Why?
Yeah.
Because
Did you not use RedisJSON or not use Redis?
we decided to use Redis, but instead of RedisJSON, we decided to use hash.
Oh, okay.
Yeah, that's because our data model gets larger as in Coupang advertisement platform, as the number of advertisements gets larger, then our JSON model gets bigger too. So that's why we decided to use hash instead of
So
RedisJSON.
when you use hash, how do you search by the date? I see you have the epoch time. So what feature in Redis do you use for that? Because you
mean
ads
epoch
have
time?
active, you have active ads, you have to show
It's
the
our
active ads.
business logic.
Okay.
Yeah. So if the epoch is over the current time, then we.
I mean, which kind of feature of Redis? I'm not asking your business logic. That's
Yeah.
It's like say search because it's a key value store. You cannot search by times. How do you search by time to show?
We don't search by time. We just retrieve by the key, and
By the
then
key.
inside of client side, we filter out by the epoch, time epoch.
Okay. Thank you.
Okay, thank you. Good questions. All right, Jaewon, thank you very
Yeah,
much.
thank you.
Okay.